Please be curious if you've got 8 minutes, please, or less.
Yeah.
Because we are running
Yeah. Inshallah.
out of time.
Bismillah wa salatu wassalam ala Rasulillah. Assalamu alaikum wa rahmatullahi wa barakatuh. My name Prof. Dr. Yousif Al-Mashadani from University of Anbar, College of Engineering, Department of Electrical Engineering. My paper with the title Hybrid Intelligent Control for Magnetic Levitation System based on Virtual Reality Model. This work apply with me and by Mr. Ahmed Abbas and Dr. Samir Algburi. The magnetic levitation system has wide range application. The main application for this system is the electrical training. And now in this work will apply a hybrid intelligent controller based on ANFIS, adaptive neurovisi inference. In this technique, we used a couple between neural and VASI to apply a controller with basic of classical controller for this system. Also in this work, present virtual reality model for the magnetic levitation system and apply this controller by interface between the virtual reality model 3D and MATLAB. And the result gated by this controller very better from the classical controller. We can apply comparison between classical controller and the hybrid intelligent controller. The error less than 0.12 with the -5 digit. And this work applied with the MATLAB version 2028. The magnetic levitation system based on the control for the magnitude of the magnetic field with the two coils. The magnetic force will control the thing between the two space less than 0.05 millimeter. This is the basic technique for control the main thing. Therefore, this technique apply with the electrical training to get the speed around 950 meter per second. This figure present the mean part for this system. We can see the magnetic levitation and the current control and the controller and the photo received and then applied with the process for the software. The mathematical model in steady space form we can see by this mean equation. The mean three parameters, this delta I and volt and delta x. Delta x, that mean is the distance which we need controlled for the movement of the thing around this distance. The practical data for this system we can see in this table with the mass of 0.7 kilogram and the resistance 10 ohm and the inductance with 0.4 to 500 and like that. This practical data and implemented by the virtual reality model, the hybrid controller design proposed based on the classical controller, the starting point, and apply the neuro ANFIS, neuro and VASI controller. After the apply the training offline, get the data and apply mix it with hybrid intelligent controller, and then apply this signal to actuator, and then put the signal through the 3D 3-degree model based on the virtual reality and get the feedback to reduce the error and get high accuracy result. We can see this result. This is the virtual reality model based on the VRLM system and apply this design according to the practical limitation such as the distance and the weight of thing and like that. This virtual reality model received the signal from the package of MATLAB after the design, and the data transfer between the MATLAB and the virtual reality. And we can plot the response for this design, and we can see in the next slide. This the basic technique used for many applications. The aim for this work to control the movement of this ball with the distance around 0.5 millimeter. This the response for the classical control with the red color, and the hybrid intelligent controller with the blue. We can see this modification for apply the hybrid intelligent controller. The comparison between a classical controller and hybrid. We can see the settling time 0.1, while in the classical control 0.3, and the rising time 0.4, while in the classical control 0.1. That means the system very speed up, and the tracking error modification with the around the 3 digit, and the maximum of.
Sorry, Dr. Yousif.
Yeah, I will control the time.
One minute,
yeah.
please.
Thank you, Prof. The main conclusion for this work, we can apply the virtual reality model based on the practical limitation, and apply the hybrid intelligent controller for this system, and get good result, especially with the tracking error and the maximum overshoot. These two parameters very effect in the controlled system. Thank you very much for this listening, and any question. Thank you. Thank you, Prof. Ahmed.
By yourself as well, which is an analysis, real measurement for surface. Yeah.
Yes, Prof. We can apply the
go
second.
Ahead directly.
Yeah.
Go in paper.
Yeah.
You can.
Thank you very much. Thank you.
Go ahead, please.
The second paper with the an analysis review, real measurement for surface electromyographic signal. This paper with Mr. Majeed, Shihab, Ahmed, and Prof. Asmiet, Ramizy. The electromyographic signal, this signal measured from the construction of the human muscle, and the electromyography electroid extract this signal from the skin of the human body. Therefore, the wide range application for this signal, for such as for recognition the disease in the human body muscles, and for the interactive between human and robot application, and for artificial limbs. Therefore, the accuracy for measurement for electromyographic signal very important. Therefore, in this paper, we will present the review for practical measurement for electromyographic signal, and apply comparison between the main parameters effect for this measurement, and what is the most effect parameter according to the application. This figure presents the main component for real measurement for electromyographic signal. After received the signal from the electroid surface, will receive and then apply the process for the signal for filtering and amplification for this signal, and then put to the second stage for the software. Through this stage will extract the features for the signal, where the features is very important for the process for in this signal. This table presents the abbreviation used for the real measurement for electromyographic signal, and apply the review for the previous work in specifically with the mean abbreviation, like the intelligent electromyographic and the needle electromyographic, and also for the surface for electromyographic. Figure present the overall diagram for the electromyographic signal measurement. Basically can separate it by the hardware and software. Hardware has three main components for electromyographic sensor and amplifier and filter. Software has also three main parts. We can apply the embedded system or in the PC, the computer, and we can apply the interfacing between the two main by the intelligent systems such as artificial neural network. The analysis of the electromyographic signal very important because the electromyographic signal has characteristic around that 16 parameters like that amplitude, period, number of turn, number of mixed turn, also the number of repeated turn and like that. Therefore, in the analysis, we apply the feature extraction according to this parameter in the characteristic of the electromyographic. This figure presents the type of EMG sensor. The EMG sensor starting with the needle, but the using of the needle very difficult on the human, because this needle will put inside the muscles. After that, apply the measurement by the surface electrode. Surface electrode has many types. Some of them bipolar or inside the wire, or apply the processing embedded in this sensor and like that. This table apply the comparison between the recording of the electromyographic signal according to the type of the sensor. We can see by this table, we can comparison. We have two sensor has high sensitivity, like the third one, sensory nerve action potential, and the last one, electromyography sensor, this high sensitivity and sampling frequency 500 hertz, and two type of this is medium sensitivity needle electromyographic and signal fiber electromyographic sensor, and this is sampling frequency low when comparison with the first two type, because this sampling frequency just 50 hertz. This big difference, this big difference between the sampling will affect on the application, such as, for example, in this middle sensitivity with this sample frequency, we can not apply interactive between a human and robot, but we can apply with other application and like that. The main conclusion by this review, we can limit the type of the electrode for real measurement for electromyographic signal according to the application, because this type will limit the number of sampling and the sensitivity. Also, we can modify it, the real measurement for electromyographic by increase the high sensitivity, many wide range for research focusing with this point, because this point very important in the artificial limbs, where in the artificial limbs we must get high amplitude for real measurement electromyographic. Thank you for listening, and any question? Thank you very much, Prof.
Thank you very much for you've got the big chunk of the session, two presentation, one after the other. So please, anyone would like to ask Prof. Yousif, then he's ready to take any questions. So please go ahead. Any questions?
No, yeah.
Okay, thank you very much.
Thank you. Yeah, off you go.
Assalamu alaikum, everybody. I am Prof. Dr. Yousif Al-Mashadani from University of Anbar, College of Engineering, Department of Electrical Engineering. Our paper with title Human-Robot Arm Interaction based on electromyographic signal, done by Yousif Al-Mashadani, Samir Al-Juburi, Mohammed Abdulteef, Ali Qusay, and Ibrahem basem. This work for dissertation of undergraduate in the Department of Electrical Engineering. Many applications in biomedical engineering based on the biomedical electromyographic signal, such as artificial limbs, interactive between human and robot, recognition for the muscle disease, and like that. This work presents the full synchronous interactive between human and robot based on the electromyographic signal. The first part done by the solve the inverse kinematics for 6 degree of freedom robot and apply comparison with the solving of the inverse kinematics for 6 degree human arm by using the 3 degree of freedom in shoulder joint and 1 degree of freedom in elbow joint and 2 degree freedom in wrist joint. Second part present the apply the scheduling for the limitation of 6 degree of freedom robot movement. That means apply the envelope of the movement of the robot based on the inverse kinematic solution, and then apply connecting between the human arm and robot arm based on the Arduino controller. Basically, electromyographic signal is the stochastic random signal extracted from the skin of a human body when the muscle is applied the construction, when it is received the instruction from the human brain. That means the electrical signal transfer through the nerve, and when arrived the muscles will apply construction, therefore will get on the human skin electrical signal with millivolt and millisignal. This signal is described by stochastic random signal because momently this signal change and all the parameters or all the specification changing from time to time and from muscle to muscle according to the number of the motor unit and the cross section of fiber in the muscles and like that. Therefore, the real measurement for this signal very difficult. In the human arm, have 3 main joints: shoulder, elbow, and wrist, and we have 9 muscles: deltoid and biceps and the triceps, and 4 muscles for extensor and flexor in the lower arm. We used these muscles to transfer the movement through the robot arm. The robot arm used for this work by this model for 6 degree of freedom. The movement of the joint applied by according to the real movement of the human arm. That means shoulder joint in the human arm movement from 0 to 180 degree. Therefore, this robot arm, the basic joint rotate by the 306 degree, but we apply limitation for 0 to 180 degree, and the also same as the elbow joint, while the gripper according to the limitation of the human hand will limitation by 0 to 45 degree. Therefore, we apply the full comparison between the human arm and the human robot. The practical implementation for the human robot arm interaction present by this figure. We can see we have a servo for robot arm with the 6 variable resistance, and we have 6 degree robot arm, and we have power supply and Arduino controller and the computer. The computer just used in the first stage with the apply the setting for the limitation of the robot arm joint movement, and for the uploading the program for the Arduino controller. After that, we'll apply just interactive between the human and robot arm. In this video, we can describe this movement. We can see when apply the movement of the abduction and adduction for the wrist or the twisting of the elbow, we see the rotating and the abduction and adduction for the wrist with the full synchronous. This work very difficult to implement with the Arduino controller because we know the Arduino controller is the simple controller with the full synchronous. We used two sensor for the electromyographic electrode surface to apply we can done full synchronous in the same time with the left and right arm. We can conclude from this work, we can apply develop the electromyographic signal to implement the movement in the manipulator system, and the result proves the full synchronous between the robot and the human arm with the simple controller and with the low cost. That means this interactive done by the cheap process. Also, the accuracy of the electromyographic signal in the real measurement with high accuracy, and this is very important in the application of the electromyographic signal. Thank you for listening, and if you have any question.
Okay, thank you very much, Yousif. That was very interesting, actually. Is there any question by the audience? I have a quick one to you, Yousif.
Yes.
So, from previous experience in such an application, the collected signal from the skin is quite noisy, very noisy indeed.
Yes.
So have you done any noise filtering? Have you done any signal conditioning? Can you elaborate more on this, please, to us?
Yes. We can see in the work we used this electrode surface sensor. This is built in the amplifier and the filtering for the noise. Therefore, this is very high quality sensor for electrode. Yesterday, I present the review paper for the real measurement for electromyographic, and I present in this paper we have two model for the electromyographic sensor with high sensitivity and high sample. One of them is this built in the filtering and the amplification process. Therefore, I overcome this difficulty by use this type of sensor.
Okay, I understand. Thank you very much.
Thank you very much.
Any more questions to Yousif? Okay, in this case, thank you very much, Yousif. Can you please stop sharing your screen?
Thank you. Thank you very much.